Hello everyone, I'm Mina Samir, got my master degree in architecture and urban design, and today I'll be presenting my research titled Enhancing Urban Mobility in Cairo, a PTV VISSIM based simulation of Salah Salem corridor. First of all, the presentation structure will be divided into 6 chapters: introduction, literature review, methodology, analysis and findings, results, and finally the conclusion. Starting with the introduction to the main problem. Over the past decade, extensive research has been done exploring the main reason behind traffic congestion in Cairo, as it became one of the most critical problems that cause financial and economical loss for Egypt. According to Cairo Traffic Index, car users do spend around 42% of their travel time just stuck in traffic. This percentage is accumulated to be around 3 days per year per person, which means more carbon dioxide emission and more pollution. Actually, the total loss is calculated to be around $8 billion per year and estimated to be around $18 billion by year 2030. Going to the significance of the study, according to Abdurrahman and Fathi, by understanding the root causes behind traffic congestion, this will allow urban planners to make informed and sustainable decisions in designing urban spaces, as well as design more efficient infrastructure and propose more efficient transit solutions. However, there is a huge debate between urban planners regarding the main reason behind traffic congestion in Cairo in particular, which is forming a gap that this research will be addressing. Which makes us ask this question: what is the most efficient urban method that can be utilized for reducing time wasted in traffic congestion in Cairo? And in order to answer this question, 3 objectives were selected. The first one is to identify the most common parameters that causes traffic congestion and its accumulation among different consecutive nodes in Cairo. Second one is to compare between research opinions regarding the most efficient strategies and tools used in reducing time wasted in traffic congestion. Third one is to provide urban planners with a clear framework that help in selecting the most efficient strategies and tools, which can be later used at any case study area. Now going to the literature. An intensive research has been done in order to collect all the previous researches and studies discussing this issue during the past 10 years and written inside the article. However, for the time of this presentation, I will sum up the reasons and the most common strategies. Starting with the reasons behind traffic congestion in Cairo. According to recent researches, they are high automobile dependency, lack of intersection management, deficiency in public transit, deficiency in road design, non-optimized traffic signaling, and bad driving behavior. Now going to the common strategies that are used for mitigating these urban issues. The first approach is enhancing mass transportation. Second one is removing bottlenecks and enhancing road geometry. The third one is traffic signaling optimization. And as you will see inside this research, a case study area is selected and each of these approaches are reflected and compared at the selected area using traffic simulation tool called PTV VISSIM, which is one of the most accurate and easy softwares used for simulating urban mobility. Now going through the methodology, starting with the important variables and measurements that are taken. First one, of course, is the road geometry, number of lanes, lane width and length, the travel time, average speed, traffic count of public and private vehicles, and of course the traffic signaling location and duration. And of course there are some essential ratios that will be taken inside this thesis, such as the existing versus optimal travel time ratio, the public and the private vehicle ratio, as well as the level of service at each intersection. And now going through a brief about the PTV VISSIM simulation tool. As already mentioned before, it's an easy way to optimize each of the related parameters, such as the travel time, traffic count, and level of service. How this will be done? Through 5 main steps, starting with inserting road geometry, then going through the traffic volume, the model calibration and validation, parameters optimization, according to of course the 3 main strategies that were selected previously in the literature review, and finally observing the best results in terms of least travel time and highest level of service. And now let's take a look over the case study area. A 3-kilometer section of Salah Salem arterial road was chosen. This corridor experienced severe congestion, particularly during peak hours, and serves as a vital link between key urban areas, accommodating high volumes of daily commuters and public transport vehicles. The selected area features a variety of traffic intersections, including multiple intersections and pedestrian crossing, which add complexity to a traffic flow and allow for comprehensive testing of congestion mitigation methods. And in order to have a precise simulation process, the case study area is divided into 3 line segments as shown, in order to track the changes along the start, mid, and the end of the road. And now going to the site analysis chapter. A site visit has been made for each line segment to identify the most congested hours for each node during weekdays and weekends. In addition, videos has been recorded on June 2024 for observing the previously mentioned parameters and ratios like number of lanes, car count, car flow, traffic lights location, in order to be inserted inside the PTV VISSIM simulation tool. However, for the time of this presentation, I will go briefly through only the first line segment AB, located at the start of the line near Imtidad Ramses and Abbasiyya Road. As we can see, the calculations show the low level of service of the first 2 points, level of service E and level of service C, which should be fixed once we try any of the 3 strategies mentioned earlier. Then all of the measured parameters that were taken at the noon peak hour are inserted inside the shown table. Now for the simulation model, after inserting all of the data shown inside the PTV VISSIM software, I had also recorded simulation videos for the current case, as well as the 3 interventions done, and inserted them inside QR codes if anyone wants to check, and I have put them inside the article. Now going back to the simulation results of the existing situation, gladly the level of service evaluation of the PTV VISSIM software do match with the ones calculated manually for each node at the case study area as shown. Now going to the results of the 3 scenarios. The first one was to remove bottlenecks and enhance road geometry at point C and point E, as both had a problem in the road width. Accordingly, the number of lanes has been changed. The second scenario, which was to enhance traffic lights, in this scenario the time of the green and red light has been changed from 60 second to 120 second cycle. Regarding the third scenario, which was to enhance public transportation, the ratio between public and private vehicles has been modified, including an additional bus line consists of 50 buses. Now let's go to the results of each approach. As we can see, the most efficient scenario in terms of reducing travel time, according to PTV VISSIM, was scenario number 1, which was bottleneck removal, by efficiency of 46%, while the least was the second scenario, traffic signaling optimization, by efficiency of 4%. This has been reflected on the level of service at each point, as we can see in the below table. Now going to the conclusion, to sum up and to answer the main question, what is the most efficient urban method that can be utilized for reducing time wasted in traffic congestion in Cairo? It was concluded that all of the 3 mentioned methods have different implication among different nodes. However, for the purpose of this research and with the selected case study area, method number 1, road geometry enhancement, was the most efficient and impactful method in terms of travel time and level of service at multiple intersections. Now for the future recommendations, different case study areas to be done using the same approach as this study in order to have a wider ground and have a better approach among different patterns of the selected parameters. Long-term monitoring and evaluation of the implemented recommendations would be essential for measuring impact and making continuous improvement based on a real-world data. Investigate drivers' behavior and preferences, which could inform targeted awareness campaigns and incentives for alternative transportation methods. Now I hope everything is clear, and thank you.